Jessica Brooks, and I'm going to show you how to manipulate kinematic equations. Kinematic equations are used in physics to describe the motion of an object. First, let me introduce my audience. My dad, my nephews, my brother, my aunt, my mom, and my niece, and my sister. Okay, so the first kinematic equation I'm going to do, first let me tell you that D is going to be equal to x minus x naught. And what this means is your final position minus your initial position. Alright, so the first equation, and I'm using D just to save space on the paper. So D is going to be equal to V initial, which is your initial velocity, times time, plus 1/2 acceleration, times time squared. Now say we wanted to solve for acceleration, your A. What you would do when you have an equation to solve for a certain variable, you would do the opposite of the operation. So for this one, I would do, since we have a positive velocity initial times time, you will subtract it. So you have D minus V initial times time, and you still have this equal, and I'm just going to rewrite this part right here so it'll be easier to see. So you have A T squared all over 2. So I just rewrote this part right here. So now, since we have a division of 2, you will do the opposite of the operation. So you multiply by 2 and multiply by 2 on this side. So to rewrite this, you have D, I'll put this all in parentheses, 2 on the outside, minus V initial, times time, and then this will still be equal to A T squared. Alright, so now all we have left is your A times T squared. So since this is an invisible multiplication sign right here, you will do the opposite operation, which is division. So you would divide this by T squared and do the same thing on both sides. So the final, alright, so the final equation will be 2 times D minus your initial velocity times time, all this equals 2A, and this will be all over T squared. Alright, that's the first one. I'm going to do 2. And the next one is a little more simple. So you will have Alright, so you have your V2, which is your final velocity, equals to your initial velocity, V1, plus AT. So let's say I wanted to solve for A again. So you would do, again, the opposite operation of your V. So this is a positive V, so you do the opposite. So you'll subtract V1 from both sides. So now this side would be V2 minus V1, and this will cancel out. So you'll have equals to AT. And since I'm solving for A, this is an invisible multiplication sign right here. So you would divide by T on both sides. So your final equation will be V2 minus V1 all over T. So that's how you solve kinematic equation, and this is actually for any equation, math equation, any kind of equation you're given. In order to solve for a certain variable, all you have to do is do the opposite operation. So if you have a multiplication sign, you will just do division to solve for the certain variable. And if you have, say I had T plus A, it's hard to write upside down, T plus A equals 0. In order to solve for T, I would just subtract A from both sides. So you'll be left with T equals 0 minus A. Alright, and that's how you do kinematic equations. I hope this was helpful for you. Those were not very hard equations. It's just doing the opposite operation for each variable. So I hope that was helpful. Again, my name is Jessica Brooks, and I thank you for watching.